Hi everyone, so in this video we're going to be talking about present value. So present value is very similar to future value. Both of them use very similar formulas, and the problems themselves look very similar. The difference is with future value, you were starting with nothing, you make payments and you add money to an account, and then you end up with lots of money in the account. Present value means that you're actually going to be starting with money in the account, usually in the form of a loan at the beginning, and those payments are what are going to be paying off that loan. So present value is the starting amount of a loan. And it doesn't necessarily have to be a loan, but for this class, that's what we're going to be really focusing on, right? And specifically, that means the money is going to be in the loan to start. You are again going to make payments, and then hopefully at the end, you end up with $0 left on the loan. That's the goal this time. So future value is you want money in the future. Present value is you want the money now, and you're going to pay it off by the future. All right, so again, the actual variables used are extremely similar. The only difference is instead of FV, we have PV. Now, for the actual formulas, there is a little bit of a difference. Instead of a positive n in the exponent, you now have a negative n. And instead of it being -1 at the end, is now 1 minus. But overall, they look very similar. Again, just like future value, I broke it into 3 different formulas. One for solving for PV, one for solving for the payments, and one for solving for the number of payments. So just like before, we are going to start just by plugging some of this stuff in. So find PV if the payment is 300, I is 0.05, and N is 72. So PV equals the payment, which is 300, and then 1 minus 1 plus I, which is 0.05, to the negative n, so this is going to be negative 72, all over I, which is 0.05. Just like future value, we get to just plug this into our calculator. Remember, if you have an older calculator, plug in this part first, and then multiply it by 300. But with that said, if we plug it in, we should get approximately $5,821.14. All right, let's do the same exact thing for example 2. We're just going to use the PMT formula this time. So PMT equals PV, which is 1200, I, which is 0.035, over 1 minus, then parentheses, 1 plus I, which is 0.035, to the negative n, so negative 24. And again, plug it into your calculator just like number 1. You should get about $74.73. All right, one more, solving for n. So n equals, there's a negative out front. On top, ln of 1 minus PV, which is 40,000, over the payment, which is 300, times I, which is 0.007, all over natural log of 1 plus 0.007. And again, plug it all into your calculator. You should get 388.22. Okay, so hopefully you're okay with plugging these in. Now let's go to the word problems, that way we can figure out how to read them and see what we need to plug in. Again, it's going to be very similar to future value. We're just going to list out our different variables and then plug them into the correct formula depending on what we're solving for. So, example 4. Denise wants to buy a TV that costs $1,200 and agrees to pay for it in 2 years at 1.5% interest compounded per month. For part A, what are Denise's payments? Alright, so for this one, we're going to start out by listing out all of our variables. So we have PV, PMT, N, and I. So PV first would be how much you took out the loan for. So in this case, Denise wants to buy a TV that costs $1,200. That's how much she would have to take the loan out for. So $1,200 is our PV. The payment, we don't actually know yet. N, remember, is going to be how many times it compounds times the number of years. Per month would mean 12 times a year. And it's over 2 years. So that's 24. Then I% would be 1.5 over, 0.015 over that same 12. And again, you can just take that percentage, move it over 2 decimals. That's going to be the top of your I divided by the 12 because it's 12 months in a year again. And in this case, it does divide nicely. So we're going to go ahead and write it as 0.00125. And then we're going to go and plug everything in. So in this case, we're using the PMT formula. So PMT equals PV, I on top, then on the bottom 1 minus 1 plus I to the negative n. And let's go ahead and plug everything in. So we have 1200, I is 0.00125, all over 1 minus 1 plus I, so 0.00125, all to the negative n, so negative 24. And then you can plug that all in your calculator, and you should get $50.78 approximately. For the next one, it's how much interest will she pay? All right, so if you remember from the last one, interest can be found just by taking that total and figuring out how much you actually put in yourself. All right, so for present value, it's a little backwards than it was for future value. For present value, interest is going to be our payment times the number of payments. That'll get us the total amount that you paid in minus the present value. That will say how much you paid in interest. So in our case, it would be $50.78 times, we had 24 total payments, because that's just our in, minus 1,200. And if we put that in our calculator, we get $18.72. Now keep in mind, this isn't perfectly accurate because we did round our payments. So the interest is going to be a little off because of that. But that's about how much interest in total. All right, let's go ahead and take a look at another one. So example 5. You have a credit card with a 15% interest rate. If you pay the minimum payment of $25 every month, how long would it take to pay off a $900 balance? You can assume no new purchases are put on the card. So whenever we're talking about credit cards, that's the same thing as basically taking out a loan. Keep in mind, the important part for this one, to not make it too complicated, is that there's going to be no new purchases on the card. That way you're not trying to pay it off and adding to it at the same time. That part can get more complicated. So this one is just, you have $900 on your credit card right now. You're going to pay $25 every month. How long is it going to take you to get that balance down to zero? All right, so again, we're going to start off with all of our variables. So PV, PMT, in I. All right, so PV, again, it's present value. It's how much the loan is at the start, so that's 900. PMT is your payment, so that's 25. In, this is going to be monthly, so it is going to be 12 times something, right? Because we don't know the number of years. So I'm just going to put a question mark for this whole thing, and that's what we're going to solve for. Then I is 15%, so 0.15, over, again, it's monthly, so 12. All right, again, in this case, I is a nice number, and I'm going to show you in just the next example what happens when I isn't a nice number. But in this case it is, so we can go ahead and write that. 0.0125 is what it's going to be. So in this one we are solving for n. So remember, just look back at the formulas. The one for n is negative ln of 1 minus PV over PMT times I all over ln of 1 plus I. All right, let's go ahead and plug it in. So negative ln 1 minus PV is 900 over PMT is 25 times I is 0.0125 all over ln of 1 plus 0.0125. From there, plug it all in your calculator. So if we plug it in, we're going to get approximately 48.13, which is essentially going to be 49 payments. All that means is that our last payment would be smaller than the rest because it's not a full payment. All right, let's go on to number 6 and see an example of doing present value So that last formula that we haven't used yet. All right, so number 6. If your car payment is $350 every month over 3 years with an interest rate of 3.5% compounded monthly, what was the original price of the car? All right, so PV, PMT, N, and I. So in this case, it's asking what the original price of the car was. So that would be how much you actually took out the loan for. So our PV is what we're going to be looking for this time. The payment's $350. N is 12 times 3 years. And then I is going to be, which is 36, and I is 0.035 over 12. All right, now here's the thing. In this case, 0.035 divided by 12 is not a nice number. It's something like 0.00291666666, and so on. Now, whenever we're dealing with interest in really small numbers like this, if we round this number, it's probably going to end up throwing our answer off. So we are just going to leave it like that and let our calculator take care of that part too. Okay, so what that's going to look like. So we're going to have PV equals PMT, and on top 1 minus 1 plus I, it's the negative N over I. So payments $350, then 1 minus 1 plus I, which I'm just going to put in as 0.035 over 12. Then raise that to the negative N, so negative 36. Divided by I again, so 0.035 over 12. So you can put this in your calculator again. Now in this case, be very careful, especially if you have an older calculator. Make sure you put both the top and the bottom in parentheses. All right, otherwise your calculator's going to do it in a different order. So make sure that you put them both in parentheses, that way your calculator knows exactly what's on top and what's on bottom. If you plug it in correctly, you should be getting approximately $11,944.54. So that's the original price of the car, and I apologize for my dog barking in the background. All right, let's go ahead and look at the last one. So the last one's going to have one extra step. So this one's going to be buying a house. And the extra step is going to be, we're going to be talking about down payment. So Alex wants to buy a house selling for $150,000. He will put $30,000 down as a down payment. So there's going to be two different parts of this. For part A, if the bank offers a 30-year mortgage at 4.99% annual interest compounded monthly, what will his monthly payments be? So we're going to start by doing PV, PMT, N, and I off to the side. And that down payment part is going to affect our PV. Okay, so if the house costs $150,000, but he's already put $30,000 down, then that means you're not actually going to be taking out a loan for $150,000. You're just going to be taking out a loan for the remainder portion of it. All right, so the actual loan amount is going to be $150,000 minus the 30,000. So in this case, it's going to get us 120,000, and that's going to be our PV. Our payment, we don't know. That's what we're going to be looking for. N is 12 times 30. And then I is going to be, sorry, not 4.0499 over 12. Again, this one does not divide nicely, so we're just going to leave it like that whenever we plug it into our formula. So this time we want the payment formula again. So PMT equals PV, I on top, 1 minus 1 plus I to the negative n on bottom. So if we plug all of this stuff in, we have 120,000. I is going to be 0.0499 over 12. Now on bottom, 1 minus 1 plus I again, so 0.0499 over 12 to the negative n, which will be negative 360. And that's just from multiplying these out. All right, I know it looks like a huge mess, but again, let your calculator do all of that work for you. All right, your calculator doesn't care how messy it looks. Again, just make sure that you go ahead and put the top and bottom in parentheses. There, your calculator knows exactly what you want it to do. All right. That said, if you go ahead and do that, you're going to get approximately $643.45. All right, for part B, approximately how much interest will he pay if he makes all the loan payments on time? So again, just like before, to get the interest, we are going to take that payment that we just found, $643.45, multiply it by the number of total payments, so 360, and then subtract out the actual loan amount, which is 120,000. All right, and if we go ahead and plug this into our calculator, we get $111,642, which is a lot of money. So keep in mind that interest grows really fast, especially on stuff like loans, and especially whenever it's a very long time. So a 30-year mortgage, it's not uncommon to pay just as much as the loan in interest. All right, with that said, that is it for present value. So again, the basics are just the same as future value. You just need to find these 4 different things and then plug it into the correct equation. The equations are already solved for you. You just need to know which one to plug it into. All right, and with that said, that is the end of this video. So thank you for watching.